What happens if you have a glass of water and you add salt and you stir it and it dissolves and you just keep doing that? Can you add an infinite amount of salt to that water? No. At some point, you're going to add a little bit more salt, and no matter how much you stir it, it's not going to dissolve, right? The solubility of a solute is limited. So we talk about saturated solutions and unsaturated. Saturated means full. It's full of water. We had some good rain last week, right? The ground gets saturated with water. It's full. And so then more rain comes down and the water just runs off. I was in Dinuba on Friday afternoon, and downtown Dinuba, the streets got pretty full of water. Because the water coming down on the lawns, it couldn't soak in anymore because the dirt is saturated, and so then it runs out to the street. And they must have some sewer drainage issue there because, yeah, it was over ankle deep up over the sidewalks. It was very, very wet. Saturated. Saturated is full. A saturated solution contains as much solute as will dissolve at that temperature. So you can't put any more in. It's full. Unsaturated just means less than that. You haven't reached the limit. So if you put a little more solute, whether sugar in water, salt in water, whatever, you haven't reached the limit yet, so you can dissolve a little bit more. These are what we call qualitative terms. There's no number associated with these, but saturated has as much as it can hold, and unsaturated is anything less. We also have supersaturated solutions. So supersaturated has more solute dissolved in it than will dissolve at that temperature. Does that strike anybody as sounding kind of impossible? It does sound kind of impossible. And not everything will do this, but what you can do to make a supersaturated solution, and I'll do a demonstration of this in lab for you, it's really neat. The solubility depends on the temperature. So if you heat a solution and cause it to be saturated at an elevated temperature, so you heat it up and you dissolve lots and lots of solute in it, and then you let it cool undisturbed, you can kind of sneak up on it. Okay, it's like it's cooling down and it doesn't realize that all of this solute shouldn't stay in solution anymore. You kind of trick the solution. So it contains more dissolved solid than a saturated solution at the same temperature. But these supersaturated solutions are unstable. And what I'll show you in lab is I can make this solution by warming it up and then letting it cool down to room temperature again, and it's still in solution. Oops. That kind of messes up the flow. Still in solution, but then by dropping one tiny crystal in it, sometimes even by just bumping the test tube, all that extra solute will crystallize out. That's really pretty impressive. The thing about supersaturated solutions is they are unstable. This is not something that you can just do on a regular basis, and it takes some effort. You dissolve it at an elevated temperature and let it cool down. So at the beginning, we said that solutions are mixtures. Mixtures are different than compounds. In a compound, you always have the same ratio of the different things, like in water. You always have the same ratio of oxygen to hydrogen. In a mixture, that ratio can vary. The composition can vary. So we can have different amounts of solvent and solute. So we have some qualitative measures of concentration. We can say the solution is concentrated or it is dilute. And so these are relative terms. Concentrated means it has a relatively large amount of solute dissolved in it. And dilute means it has a relatively small amount of solute. And it depends on what you're comparing it to, right? Let's see. All of my analogies are kind of iffy right now, so I'm sorry. Well, we don't want to go there yet, so we'll have to come up with one. Okay, rich and poor. So, take a middle-class American person, and they're driving a Toyota that they owe payments on, and they're renting a house. But, they have enough clothes to eat, and they can pay the rent, and they're getting along okay. Is that person rich or poor? Depends on who you compare them to, right? If you compare them to someone living in a third world country who's scrounging at a garbage dump for food to eat, that middle-class American is wealthy. They're rich, right? They have a television, they have electricity, they have heat in their house, they're not worried about where their next meal is coming from. Now, they might not be happy with what they've got, but they have a lot compared to that third world country person. If you compare that middle-class American to Donald Trump, is the middle-class person rich or poor? They're poor. So rich and poor are relative terms, right? There's no quantification of, well, this is what it means to be rich. Now, different people can define it in different ways, but generally speaking, those are general terms. So concentrated and dilute are general terms. They're qualitative. They don't have numbers associated with them. So you could have one solution compared to another, it might be concentrated, and you compare it to a different one, it might be dilute. But we just need to understand the relative. Concentrated means more solute, dilute means less.